Okay. Here's basically an outline of the test. You may, but not right now. Oh, you know what? Hey, you don't need to, because we're doing a video of it, right? So I'm going to go through this outline of the test because it all came from our marker boards, right? So let me take you down memory lane here. One of our first things that we did, we talked about the difference between distance and displacement. So I did the thing where I walked 1, 2, 3, 4, 5, 6, 7. What's my distance? 7. Okay, what's my displacement? 0, because I'm right back to where I started, right? We talked about the difference between average speed and instantaneous speed. Average speed is the time for it's distance. It's distance over time. It's the distance for the entire trip divided by the time for the entire trip. It's the entire trip, right? So, example of that would be if I went on it. Remember, I took that trip to Atlanta, and we were slow getting out of the neighborhood, and then we got up on the interstate. We went up pretty quick, and then we hit the outlets, and my wife made me stop, right? And then we got back, and we made on the highway, and then we hit Atlanta traffic, and then it got really slow. But I eventually reached my destination, right? So if this is a speed versus, if this is a distance versus time graph, then there were times when I had high instantaneous speed, which is the slope of the line. You can see where I had high instantaneous speed. You can also see where I had no speed at all because I was at the outlet sitting there having a Starbucks while my wife was in at the kitchen store or whatever, right? Instantaneous speed is different than average speed. Average speed is the distance for the whole trip divided by the time for the whole trip. So on my average speed would be a line that I would draw from the beginning of the trip to the end of the trip. So average speed is the distance for the entire trip divided by the time for the entire trip. Okay? Come on in. Have a seat. No, don't talk to me about that right now. You're on camera. Okay, and velocity versus speed, we talked about that today. If you were on a carousel riding one of those little horses, or like a merry-go-round, if you were going round and round, even if the carousel was going at constant speed, you still experience acceleration. You feel movement. Even though the carousel is going at a constant speed, you feel movement because you're changing direction. So, and we talked about when you're late for school and mom is driving you to school, and she's going the speed limit, she's going at constant speed, but you feel when she goes around the corner like you need to hold on to something, right? You feel that movement because you're changing direction. Yep, got it? You're right here. Okay. So we talked about terms, not just the definitions, but you need to be able to compare these two. What are the differences and similarities? Distance versus displacement. We had this crazy map where we said, okay, here's where we start. Here's the pot of gold over here. As the crow flies, the displacement is only 20 miles, but then I made you draw this circuitous route covering a distance of 70 kilometers to get to the gold. That was just on one of our early worksheets. And then what we need to do is we need to, working down our list here, we need to be talking about the speed equation. You need to be able to do the speed equation. So we have one of these triangle gimmicks, right? Where if you want to calculate speed, put your hand over speed, it's distance over time. If you have a word question that's asking you about how far something went, it's speed times time. So we have all the different equations for speed, solving for the different variables, but we had this nice little gimmick, right? And so when you get your paper, maybe the first thing you do is write this little triangle so that you always have that. Let me take a step back and say, in this unit, we are describing motion. We are describing motion with words and graphs, with numbers and graphs. You guys, really, this all boils down to, can you tell me how far did it go? How fast did it go? How long did it go? Really, that's all. We're only answering these three questions: how long, how far, and how fast. You remember the great race, and we were out on the bridge and we ran a race, and then we came back and we looked at the man versus hamster. Remember, again, I'm going to reiterate the difference between the average speed. The person who won the race had the shortest average speed, but somebody who was like slow in the beginning and then decided to speed up at the end, they had a faster instantaneous speed. So in this one, can you tell who won the race? But that's not the same person who had the fastest instantaneous speed. So reading distances versus time graphs, that's really important. Then we moved on to the concept of acceleration. What is acceleration? It is the change in velocity, the change in speed over time. In general, it's just the change in, that's what this delta means, change in speed over the change in time. What does change in mean? It means final minus initial. So change in speed is the final speed minus the initial speed. You have to get the order of these right, because if you don't, when you plug in numbers, you might not get that negative sign you need when we're trying to decide whether we have positive or negative acceleration. It matters which one you subtract from which. I made a big point in class that this equation is not foreign to you. If you have been in a math class and they've talked about the 2-point equation for determining slope, that's all we're doing is trying to determine the slope on a velocity versus time graph. This is really just the 2-point equation for determining slope, is this equation for acceleration. Okay. So again, we had another DOA. If you look back in your notes for this class, you should see, like, you would come in and I'd give you a DOA, and the topic of the day was acceleration. So you had to define it. You had to write the formula for it and maybe give me some examples. Also the units. You need to know the units because that was the first question on the quiz, right? Was what are the SI units for speed, or what are the SI units for acceleration? And this board says if the SI units for distance is meters and the SI units for time is seconds, then the SI units for speed would be meters per second. SI units for acceleration, you need to know what that is too, right? So I'm walking you through all this. Some of this you'll have to review on your own, make sure you have all the answers. A-Day did not get to do the gallery walk. We will do that on Friday. The gallery walk, if you'll look around the room, I've got 6 of these motion graphs posted, and you'll get in groups and you'll walk around and you will have a story. And the story relates to one of these graphs. And so you and your group have to make a connection between the story, the motion described in words, and the motion described in graphs. So you will decide which story goes with which graph. So B-Day had a little bit more practice with motion graphs, but A-Day will get that practice on Friday. You need to understand that a curve in the distance versus time graph means a straight line in the velocity graph. Constant speed is a constant slope, and distance versus time is a horizontal line in the velocity. So when you go from one graph to the other, you change the shape of the lines. But these all describe the same motion. So I think I had all of you draw these motion graphs in your notes. Your notes are really important. You need to keep up with them. This DOA goes with this graph. Basically, this is the story of a runner running a race who speeds up, runs at a constant speed, crosses the finish line, slows down, comes to a stop. Those are the kinds of stories you need to be able to interpret with motion graphs. Okay, and the last board, second to last board, looks like there were the 3 subjects that we tacked in on the end. We talked about momentum, and we talked about projectile motion. Basically, if you can guess at the answer, then you can solve these problems. I'm just going to give you a word problem. You have to determine the given information, determine what is unknown, what are you trying to find out. You'll be given an equation. You'll have to pick the correct one, and then you just substitute and solve, and that is the guess method. So basically, it's everything that was on the quiz plus these last items on momentum, projectile motion. But these word problems you'll just be able to plug and chug on. So that is the review for the test, just telling you what all is going to be on it. how can you practice? How can you study for the quiz, for the test?
Flashcards.
I would have flashcards for the vocabulary, definitely. I would have flashcards for the units and the formulas. Right. I would make yourself some compare, contrast, some T-charts, similarities and differences. Compare and contrast similarities and differences for these three terms, definitely. So vocab is just one, but that's just like, that's not really a skill. That's just memorization. This takes a little bit more critical thinking, right? And then being able to solve these problems, that's higher level of knowledge. Being able to read a story problem, determine what they're asking, and solve the problem. So that's the higher order thinking. Okay. I know. It's Katie's brother. Okay. I'm going to stop the video there for my friends. So next week, beginning of the week, in time for me to grade for progress reports.